Hello YouTube listeners, this is your friend Dr. Satish Singhal, PhD, Professor of Computer Science at Community College, Torrance, California. Today I want to talk about this program development technology called IOAA Technology. There are two videos. Um, this one we just talk about fundamentals. Next one we show a concrete example and we'll tell you what IOAA means. So what does IOA stand for? The full form of IOA is Input Output Analysis and Algorithm. And with inspiration provided by Professor Masood Gyam at Computer Science Department at El Camino College, I developed IOA technology as a very powerful method to learn computer programming for the introductory course such as CSCI 1. El Camino students who went to obtain university degrees have reported back to me that they have found this technology to be so powerful that they used it to learn many other engineering subjects as well. And eventually IO technology becomes part of other technologies such as object-oriented design when larger industrial strength programs are written. Okay. So what are the components of IOA technology? Input-output analysis algorithm. So IO technology depends upon following characteristics of digital devices that run based on an operating system or execute an algorithm inside a loop. So typically device or computers provide an input. Input may be done, and input is data input always. Input may be done by one or combination of input sources such as keyboard, data files, databases, pictures, videos, audio files, web pages, interstellar devices, and modern devices such as smartphones also get input through fingers, voices, cameras, and gestures. And user making input expects one or series of outputs. You just don't make input for no reason, you expect an output. Input and output can be interactive processes, such as in video games. You're constantly giving input and getting an output right away. So the goal of programmer is to study all inputs being made to the computer in a program, understand the destination of program in terms of output specifications, like, okay, so I made input, what output I'm going to be expecting or getting, and then carry out two steps before writing the program source code. So what are those steps? Understand that no step is done unless document for the previous step is written down. Next two steps are analysis and algorithm, and we describe them in the next slide. Okay, analysis step of IOA analyzes the following. All the mathematical computations the software to be written is expected to perform, we find those out. We collect all the math formula used in these computations, and then we convert those to C++ form of math formula to be used. This might surprise some of you that some math formula cannot be used in C++ source code in their math form. Typically, always a translation from math form to C++ form is required because math formula are not usable in computer programs. Analysis also needs to figure out what kind of control structures the program would need to use. And three main control structures are sequential. Program statements are executed line by line from line 1 to 2 to 3 and so on. Selection, that means we are selecting certain piece of code and ignoring certain other. And looping means that we are iterating through same code, executing same code again and again until some condition stops looping. These are all described in chapter 1 of Singhal ebook under section Algorithm and Software Development, page 28. And you have access to that. My students have access to that. So you can take a look at that and read that for more details. Selection and looping is done based on testing of certain Boolean conditions, whether they are true or false. We will talk about Boolean conditions in a lot of depth when we start to learn about if and else structures. And design of input Boolean conditions itself depends upon input variables and what outputs are actually desired. Analysis depends on input and output and variable chosen for them. If variable mapping is an error, then analysis will also be incomplete. If formula used are wrong, then also analysis is incomplete or wrong. Okay. Then we talk about algorithm after analysis. Algorithm writing using a technology called pseudocode is the last step to be completed before using the algorithm as a foundation for writing source code. Source code is the final program. So what is algorithm? Algorithm is defined as a set of step-by-step instructions given to the computer to solve a problem in finite time. So it must be step by step. It must end in finite time. That's called a property that all algorithms should be halting algorithm. They should halt at certain time. Instructions that do not lead computer to solve problem in finite time are not algorithm. Writing algorithm in pseudocode language is the key foundation for writing computer source code in programming language. We write the algorithm pseudocode language first, and then we convert it into source code in any programming language you want. So a fact is that algorithm is generally as independent of programming language as possible. Pseudocode is named so because it is neither pure English nor pure source code, but it is a mixture of two, and it has formula and symbols. Okay. More on algorithm. Chapter 1 and 2 of Singhal ebook give more detail on algorithms. In fact, algorithms which depend for their foundation on previous steps such as input mapping, analysis, and output mapping are the most important concept in computer science. So those of you who thought computer programming is just dashing certain source code lines in a compiler, compile, run it, and that's it. No, that impression is 100% wrong. So let me say again, thinking that algorithm is unimportant, that impression of computer science, computer programming is 100% wrong. If you take out algorithm, then there's practically nothing left in computer science. Computer and every digital device you see doing nothing but execute algorithm. Central importance of algorithm is illustrated by the fact that at junior level of computer science class, every computer scientist must complete a semester-long course called analysis of algorithm. What are the steps after completion of IOAA? After completion of IOAA, programmer does the following. Programmer takes the pseudocode and converts to source code using the rules of programming language. You can use any programming language that your organization has decided. In this CS1, we'll use C++. You compile the source code, and there might be some compile error, which is syntactic error. You fix the compile error, then you execute the program, and you might have typed a formula wrong or something that is preventing the correct result. Those errors are called logical or runtime errors, and they prevent output not matching the required output results. We fix those, and whole process is shown in the diagram in the next slide. So we do input mapping, we do output mapping, we do analysis. Based on these three, we do algorithm development, then we do source code development, then we fix the compile errors, we fix the logical errors, and then we test our software with the wide range of data to make sure there are no other errors actually. So remember this diagram very well. I would like you to maybe print this one out and keep that with you to see the overall. Every program you write, you're going to go through this diagram and make sure you complete all parts of this diagram and not rush through any steps basically. Okay, there's a technology called stepwise refinement. We have shown in previous slide as if we just go linearly from here to here to here to here. No, it's not like that. These two are simply variable naming and data type determination. Then we go to analysis. There might be something wrong in analysis that's going to mess up this. So we might stay between these two steps for a while. And then we develop source code and fix compile error. Well, we might stay in this loop for a while, and so on. So it's not linear process from one step to another. Any error input output mapping will pass to analysis, and then analysis will become errant. Further errors can be added in analysis that would pass errors to algorithm. Errors in algorithm would cause logical errors preventing the desired program output. There is a technology called stepwise refinement that is used to iterate through all IOA steps, source code refinement steps, compiling and executing, and keep refining them until desired output from program is achieved. So we cannot assume our steps are perfect. We need to refine between steps. That's called stepwise refinement. Meaning of stepwise refinement is that refinement of every step taken to write computer program may be done until output meets specification. Okay, so in part 2 of this video, we are finished with part 1. We'll show you an example of use of IOAA technology. We will take a programming problem. We'll go through input mapping, we'll go through output mapping, we'll go through analysis, we'll go through algorithm development, and last part would be that we will actually write a C++ computer program, and we could type that program into a compiler and show you running that program. That might be done in third video though, not in video number 2. Okay, once again, this is Dr. Singhal, your friend, and from El Camino College, Torrance, California. And thank you for watching. Somehow yeah.